In the name of Allah, the most gracious, the most merciful, praise be to Allah and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and companions altogether. Now, after finishing the general discussion in the first episode and talking about topic, in the second episode, we begin with you a new episode, a new challenge, and practical information that will benefit you in the job market about the seventh test is the CT secondary injection test. The purpose of this test is to ensure that the current coming out of the CT secondary side of the three phases, red, yellow, blue, has reached the last point in the same order, red, yellow, blue, without any boundaries or mixing between them. The CT secondary injection test involves injecting three-phase current using a secondary kit like the CMC. Current is injected at different values for red, yellow, and blue phases to ensure correct phase alignment. We inject 50% of the rated current at 0 degrees for red, 75% at 240 degrees for yellow, and 100% at 120 degrees for blue. A clamp meter verifies the current along the path. At the relay, check the current on the relay's display to ensure the city ratio matches the drawing. Discrepancies require written or email approval. Verbal approvals are not accepted. The city ratio in the final setting is not adopted without approval. If the angle on the relay is incorrect, it's not an issue as the relay needs a reference voltage for accuracy. At the relay, it's crucial to measure the current value behind it and verify the display to ensure the city ratio matches the drawing. Discrepancies require written or email approval. Verbal approvals are invalid. The final setting's city ratio isn't adopted, and the drawing is adjusted per the relay, but changes need approval to avoid liability. If the relay's current angle is wrong, it's not an issue as it needs a reference voltage. If the injector or CMC won't inject current, it could be due to an open circuit or high impedance protection. Locate the open circuit or use a temporary jumper on the series resistor for high impedance protection until testing is done. City ratio isn't used. Drawing changes per relay. If relay angle is wrong, it needs reference voltage. If injector or CMC won't inject current, it may be due to open circuit or high impedance protection. Locate open circuit or use temporary jumper on series resistor for high impedance protection. Before STT secondary injection test, ensure test switch creates short circuit on STT secondary and open circuit on VT test secondary when inserted. In some cases, if the injector or CMC refuses to inject current, this is due to two reasons. Either there is an open circuit in the current path, or there is high impedance protection in use. If there is an open circuit, it needs to be located. However, if there is high impedance protection in use, a temporary jumper should be placed on the series resistor until the test is completed. And don't forget to remove this jumper after finishing the test. Before completing the STT secondary injection test, we need to ensure that when inserting the test switch into the test plug, the test switch should create a short circuit on the secondary circuit of the STT and an open circuit on the secondary circuit of the VT test. You can see this when we plug it in. This is the first step, okay? The CT, an open circuit on the secondary circuit.
The second way, go inside quickly. When the car is closed, the car will stop closing. You can't close it at the moment. Unfortunately, this is currently closed. Then you need to send the key. Send the key. Close it.
This is usually verified by keeping the injection through the secondary kit while simultaneously inserting the test switch into the test plug. If the secondary kit stops injecting, it means there is an open circuit. If it doesn't stop, it means there is a short circuit and the current path remains closed. This method, it may be somewhat directed towards the device in case there is an open circuit. The current circuit should never be opened during injection, and we must also ensure that there is a short circuit facility on the CT terminal block link if we want to isolate the relay for any reason. The terminal block link, if we want to isolate the relay for any reason, the eighth test is the static burden test, which defines the burden as the resistance value of the secondary circuit at a specified power factor and when the secondary rated current is flowing. It is usually expressed in apparent power, with the unit being volt-amperes. One might ask how the burden can be considered a resistance while being expressed in volt-amperes. Here we say that the burden can be expressed in ohms, amperes, or volt amperes, and one can derive one from the other. From the definition, we stated that the burden is the resistance value of the secondary circuit at a specified power factor, which is determined to be 0.8, if the burden value is greater than 5 volt amperes. When the burden is 1, it is resistive. We deduce testing. Burden is secondary circuit resistance at a power factor. When secondary current flows, we inject 1 or 5 amperes based on CT ratio. Injection is after first TP, post CT, and before TP opening towards relay and meter. If CT is in service, short circuit TP. Before opening, when secondary current flows, inject it, either 1 or 5 amperes based on the CT ratio. Injection occurs after the first TP following the CT and before opening the TP towards the relay and meter. If the CT is active, short the TP before opening it. Inject rated current towards the relay and meters, then measure voltage across secondary circuit terminals. Multiply these to get volt amperes. The burden includes load resistance, meters, relays, and wire resistance. Note, VT burden test applies rated voltage and measures current. CT burden test inject current and measures voltage. Typically, the burden test follows CT secondary injection using the same kit and injection. The 9th test is the STT primary injection test. Usually STT is tested at the first terminal block TB, with secondary injection at the first TB. Often the TB itself is untested and may be defective. Primary injection ensures all circuits from STT to the endpoint are correct. The VT burden test is done by applying rated voltage and measuring current, while the CT burden test is done by injecting current and measuring voltage. The burden test is usually done after the CT secondary injection because we inject the rated value from the same kit and the same injection. The 9th test is the STT primary injection test. The STT is tested at the first terminal block, TB. Often the TB itself is not tested. Primary injection ensures all circuits from the STT to the endpoint are correct. The primary injection test includes the secondary injection. It's better to do the secondary injection first. The primary injection test involves injecting current on the STT's primary side from B1 to B2 using a device like the Odin, then reading the current on the secondary side. The primary injection test includes the secondary injection test, but not vice versa. Conduct the secondary injection test first, as its kit is cheaper. Errors found can be fixed before the primary injection test. Most errors are corrected in the secondary injection. For the STT, the primary injection test involves injecting current. Using the kit is cost effective. For the STT primary test, inject current from B1 to B2 with a device like Odin, then read the secondary side. Test each phase separately, red, yellow, blue. Start with 50 amperes to check for unusual sounds or open circuits, then increase to 40% of the primary current. If sounds occur, turn off the device and check for open circuits. Usually access only one CT end. Connect an Odin cable to the red phase with the return from the adjacent feeder's red phase. The primary injection test is done for each phase. Start with a small current. Increase the current to 40% of the primary current. If unusual sounds occur, turn off the device and check for open circuits. Connect an Odin cable to the red phase and the return cable from the red phase of the adjacent feeder to close the circuit. Red must connect to red, yellow to yellow, and blue to blue. If any unusual sounds come from the CT while increasing the current value, the device must be turned off very quickly, and we need to ensure there are no open circuits in the secondary circuit of the CT. In most cases, we cannot access both ends of the CT, P1 and P2. We can only access one end. In this case, we connect one of the Odin cables to the red phase in this feeder, and the return cable will be from the red phase of the adjacent feeder to ensure the circuit is closed. To ensure the circuit is closed, a common mistake in the connections is connecting the red phase in this feeder with the yellow or blue phase in the other feeder, which results in an open circuit. The red must be connected to red, yellow to yellow, and blue to blue to keep the circuit closed. As for the GSV, the primary injection for the CT is tested through the 2 earth switches located before and after the CT, after removing the grounded cable, of course. The connection is made from the red phase of the first earth switch to the red phase of the second earth switch. However, for the pushing CTs located at the ends of the power transformer, it is never possible to perform a primer injection on them. They are tested through the transformer stability. After completing the CT test and the secondary and primary injection tests, along with the stability test, it is preferable to place a masking tip on the CT terminal block. This means that touching this circuit is strictly prohibited until the station is operational.
One of the important methods in operating the area is to achieve all zones, both the conservative zones and the moving elements, for proper communication. The best way to achieve this involves identifying improvement points highlighted through the moving conservative phone zones, where the conservative zone points are realized through the conservative area. This allows for demonstrating balance calculations and movement decisions. Work must be defined at each stage. The procedure will be repeated 3 times for the cancer process case, sharing reports, allocating time, and dividing steps. Moreover, the work must be defined at every stage. However, the procedure will be carried out 3 times continuously in designing the actual process case for the cancers. Once the trial is done, sharing reports across all areas, allocating appropriate time, and dividing occurrences across the steps, the new traptor from Euro SMC pushes a 3 times strong and sustained force, which in combination with its different sustains, allows work to be achieved quickly and easily. You just have to communicate with all the steps in one of the 3 steps. And you have to communicate with all the 3 steps. And you have to communicate with all the 3 steps. And you have to communicate with all the 3 steps. And you have to communicate with all the 3 steps. And you have to communicate with all the 3 steps. And you have to communicate. In the end, you just need to compare the reports in the conservative districts for theoretical industries, and you should decide on the errors, or how to use them. The TreeRaptor is a set of 3 Linktor devices, one of the essential Euro SMC devices, which can also be used differently, to achieve initial training, sequence reporting, current sequence reporting, and many other transactions, the coordinated design and 100 other marketing strategies. The renaissance of a nation.